anything, you had to call a function. Everything was a function in this language, right? So the paradigm was call a function, which calls another, which calls another. And we get things done by passing data around and having a few side effects here and there. And then in 1958 and 59, we get Flowmatic and COBOL with Grace Hopper developing these ideas as COBOL. And the target audience was programmers, but also administrators and accountants, people who weren't comfortable with functions. And so the language ended up looking more like English. And guess what? No functions at all. So there's the start of it. And for many years, the state of programming languages was like this. If this is the world of programming languages, Lisp was on one side, being the functional language. COBOL and all the other languages ended up being procedural. And of all the languages on the procedural side, COBOL was, in some sense, the most procedural because it had no functions at all. So how did COBOL get away with that? How do you get away without functions? Well, they decided to go this way. We'll have global data. We'll make a very simple organization. If you declare a variable, you can see it everywhere. Even an accountant could understand that, right? If they see a variable in a program, that variable is available to you everywhere. So global data. The main organizing principle ended up being paragraphs, right? Programs end up being sections and paragraphs and sentences. And the sentences are phrases and words. It's organized like a book. So again, an accountant could be comfortable sort of reading a COBOL program. And that's how they got away with it. How'd that work out? Great. The world's largest business is run on COBOL. This has been a very successful strategy using global data where I can see every variable everywhere. If I'm a programmer, it sort of makes my life simple, right? I don't have to worry about getting access to the data. If I see it, I have it. I don't have to pass parameters. That makes it sort of efficient in some ways, right? I don't have to pass parameters around. It's completely procedural, and it's easy to add more code. I can just start writing another paragraph. Well, every decision has a flip side, and the flip side is if it's easy to add code, I end up with these, especially for programs that live 20, 30, 40 years, I end up with monolithic programs that are these huge beasts. And some programs have gotten so large, it's difficult to understand what they're doing. And one person might take months to figure out what a program is doing. And the other flip side of this is that if a variable goes bad, since everything's global, I have to look sort of everywhere to figure out where it went bad. Another downside to that is if I want to reuse my code, I have to copy it. There may be a collection of paragraphs I could use, so I copy and paste, but what I'm not copying and pasting is the context surrounding all those paragraphs that make the paragraphs I want work in my new program. So I'm faced, if I can copy and paste, but I'm faced with having to test and debug again. And then when I think about things, if I'm writing a program, when I finish writing the code, I think I'm about halfway through. The rest of it's testing and debugging. So that's a significant part of the process. 60 years later, functions are still a winning idea. Most modern languages, even those that don't start out as functional languages, have functions, right? I can't think of another language. There may be some, but I can't think of one off the top of my head that doesn't have functions. But, and in fact, a lot of languages are moving toward the side that Lisp was on. They're trying to introduce functional programming ideas, not just the idea of a function, but actual functional programming ideas. And we've run into Scala, which was designed from scratch to be hybrid. It was designed to be both procedural and function. The interesting thing is COBOL is also a hybrid. COBOL, the press has this idea that COBOL is old, which is true, but it's also new, very new. And so COBOL is also a hybrid like Scala. In this case, it's procedural and object-oriented. So if I'm a programmer wanting to design functions, what can I do now if I'm working in Enterprise COBOL? One alternative is the language environment. There's something called a language environment that provides many functions to us that we can use. Just to give you an idea of what this is, we're not going into it in much detail, but basically the language environment is a runtime environment for a variety of languages like C and C++, Fortran, PL1, Java, COBOL. They all run in the language environment. And within this runtime, there are functions available to all of these languages. These are not the functions we're going to talk about today. So I'm trying to put this in a little perspective. There are functions that exist in the language environment that all of these languages can use. But the functions we're talking about today exist here within COBOL. So what can we do now? Well, we can use what are called intrinsic functions. Enterprise COBOL still does not permit user-defined functions, but has plans to add them. Tom Ross was nice enough to correspond with me on this point and remind me that the COBOL standards, the COBOL 14, which defines what COBOL can be, actually allows for user-defined functions. But the actual implementation in Enterprise COBOL currently doesn't have it, but there are plans to add this as a feature. I'll give you a little teaser here. There is a workaround that I want to suggest that you might not think about immediately for writing your own functions. We can't actually do that, but we can get close. And as a teaser, I'll mention, we'll get back to this right at the end of this talk. So for the moment, what we can do are use the intrinsic functions. Those are the built-in ones that COBOL has, and they can do all sorts of things, mathematical, character, and logical operations. And what functions do is allow you to reference a value that's going to be computed during execution and use it in some kind of syntax. So the way this happens in COBOL is it looks like this. You have the word function, and then the name of the function. And if it has parameters, some functions don't. There are at least two I can think of, current date and pi, which don't take parameters, but certainly min does. I can pass some parameters in and compute a minimum value there. The advantages of these intrinsic functions is they work correctly. That's always a big advantage. They're reusable and they're very efficient. They've been written with efficiency in mind. It's unlikely you're going to be able to do it any better yourself. So it makes sense to call these functions if you have these sorts of problems to solve. Also, they solve a variety of different problems for us. The pattern, again, is the word function, the function name, and a parameter list in parentheses. Here's a couple of examples. Function random, which returns a random number between 0 and 1. This is a seed. I can give it various seeds to get various sequences of random. These are pseudo-random numbers, of course. And what comes back to me is a number, and I can capture it with a compute statement. This is a numeric value. I capture it with a compute statement. Here's an alphanumeric function, reverse. I can give it a string. It gives me the reversed string. And I can capture what comes back by moving it to a variable. So there's 6 categories of intrinsic functions: mathematical, statistical, some date and time functions, some financial ones. I'm not going to look at those today, some character handling, and just some general functions. There are about 70 of these things. And if you should look into this just to read the list. If you're trying to learn intrinsic functions, the first thing you should do is just read down the list. What are the names of these functions? You'll know immediately what many of them do. And if you actually have to use them, then you can certainly start reading the manuals about it. To find these things, you can Google Enterprise COBOL Documentation Library. That's the best place to go. Choose the correct version of COBOL. Like, there's a variety of versions. And then what you want to look for is the COBOL language reference and the COBOL programming guide. Both of those are excellent. it's hard to find better language documentation than what you can find in these COBOL language reference and programming guides. The language reference basically defines what COBOL looks like and does. The programming guide gives you lots of advice on and examples of how to code these things. So I'll start with some tips for beginners. If you're just getting started, coming to this from a different language, or you're just starting out in COBOL, the first thing I would suggest is code the parameters without commas. Now that's my opinion at this point. So that you can put commas to separate the parameters here, but if you do that, you have to put spaces after each comma, which to my eye looks a little funny. So my strategy has always been to just separate the parameters with spaces. I think it looks good and it's easier for me to remember. If you're just starting this, your experienced programmers can cover your ears at this point, but if you're just starting this, the syntax rules for using intrinsic functions can seem a little confounding if you're just getting started, particularly if you've programmed in other languages. As an example, if you code display function max ABC, the compiler will reject that. If you're coming to this from Java or some other language, that probably looks like something that should work. It doesn't, because this function returns a numeric value, and display doesn't work well with numbers. It is capable of displaying strings and things like that. So this does work, right? This doesn't work, but this, which looks very close, does not. So using these things can sometimes be confounding. It takes a little experience to get used to where can I code these functions and how can I use them in various ways syntactically. So my initial advice to you is don't try to be too fancy, at least at first. Get a little experience under your belt and then start experimenting. So here's my tip. Try this. If you're calling a numeric function, use a compute to capture the result. In other words, fire off the function and capture it using a compute. That's for numbers. If you're working with alphanumeric numbers, move the data to capture it. So you'll do a move on this string that comes back to you to this variable. After you've captured them, then you can compose some fancier syntax to work with the results. That's my beginning advice to you. Let me close these things to get rid of this. All right, so that's my beginning advice. One of the reasons for using these functions is that they work well, and by well, I mean great, with tables. That's one of the main reasons to go to intrinsic functions. If you have tables that you want to play with, if you want to sum up a table or find a minimum value in a table, or find the position of the minimum value in a table, or find the maximum value or the position of the maximum value. If you're doing statistical functions like mean, median, range, standard deviation, variance, any of those things, all of those functions work great with tables. So I created a little example here. I created a sequence of values called test values, and then I do a redefines to define it as a table or an array, right? T redefines test values. What is a T? Well, it's a row that occurs twice, and each row is an item that occurs 4 times. So I get a table that looks like this, 2 rows of 4. Once I've done that, I also have this table result thing, which is numeric-edited, right? The actual items in the table are numeric in this case. So here's my examples. I can say function sum T, and then I use this magic word all, which is why this is so brilliant. If I code the word all, it's as if I had typed all of the subscripts myself and passed the parameters into this function. So by coding all on a 2-dimensional array, basically I'm asking it to sum the entire array. Well, that's brilliant. I don't have to code loops to get what I need out of this table. I don't have to worry about initialization problems. I don't have to worry about being one-off problems. If the table changes, I don't have to worry about the size throwing my results off, right? I can just write one line that sums up this table and I've got the result. That's the brilliant part of it. You can use it in other ways. For instance, if you have a 1 in the subscript, that would sum the first row, the blue row. This works with single dimensional tables up to whatever the maximum result is, 5 or 6, I forget what the maximum number of subscripts you can have, more than we'll ever need. So this is one place where intrinsic functions works brilliantly, and this is something you should know about. The rest of the things I'm picking are somewhat arbitrary. I've just tried to focus on a few of these functions to give you an idea and advise you to poke your nose into the manuals to investigate the details of the ones that you might be interested in. But I tried to pick some common features that COBOL programmers can use in a variety of business programs. One of the things you might have to do is to take a value like this, a user-defined value, or maybe the user typed a value on a kick screen, or somehow the user created what they thought was a number, and you're having to deal with it as a programmer. Well, I can't really deal with this to do arithmetic on it, so I have to do a conversion. So I'm either faced with having to parse this somehow, and that would be a significant parsing problem to extract the number out of this thing. But there is an intrinsic function that will do that for us, numval-c. The C, I think, stands for currency. In other words, this value they're giving me can have a pound sign or a dollar sign. Currency symbol can have decimal points, commas. And this value will extract the numeric value and save it. So this numval1 is actually a numeric field that has the equivalent number. Now I'm making this a little simpler than it actually is. There are other functions that you can use, test functions that go along with this, so that you can test these values you're passing to numval-c. In other words, everything that you throw at it isn't going to work. So you might want to do some testing on this field before you actually fire off this function. And I'm not showing you that. Again, check out the user manuals for that. But you get the idea. Another thing that programmers sometimes do is change coding encodings, right? So we can move from EBCDIC to ASCII, or vice versa. The way this works is we're going to go through Unicode as the middle ground. So IBM has a data type called national in COBOL. It's actually Unicode, and the version of Unicode is UTF-16. It's 16 bits. And this Unicode, or national data, incorporates lots of different encodings, 2 of which are EBCDIC and ASCII. IBM describes encodings as code pages. So there's an EBCDIC code page, and IBM numbers them. So that 1140 here is the code page number for EBCDIC, and 819 is the code page number for ASCII. I need some EBCDIC input. I'll just create a little field, ABCD 1, 2, 3, 4, and I have a field for the output. I have a function for that. There is a national of function that will convert from here to here. And then there's a display of function that converts from here to here, right? So we'll go through 2 conversions. Now I'm doing what I just told you not to do, right? I'm firing off a function inside of a function. But I wanted to show you that that is possible. And in fact, this is a nice way to do this. So let's just briefly walk through it. If I fire off national of, I give it my input, and I input the code number as well to tell this function that this input is in EBCDIC. So what comes back to me here is national, in other words, Unicode. And then I'm giving the Unicode to this function, display of, and telling it that I want to convert it to ASCII. And that does it. I am following my advice here, so I'm firing off a function and saving it. Since it's a string function, I'm saving it to AO. And that's in ASCII. And I'm playing on an EBCDIC machine, so I can't really display it very well. So I do one more conversion, say, okay, convert it to hex, and let's see what it looks like in hex. So there's 3 different conversions you can do, and you can play with. And you can go pretty much from any encoding to any encoding that can be represented in Unicode 16. There's a few more sample. Again, this is kind of completely arbitrary in some sense, what functions I'm picking. I'm just picking some of the ones I commonly use or might choose. If you're working strictly in EBCDIC, these 2 are handy. I can pass in an integer and ask what character is that. So if I give it 241, it tells me, oh, that's a 1 in EBCDIC, a character 1. And if I give it a number 107, it tells me, oh, it's a character comma in EBCDIC. And this is the inverse function. If you give it a character, it tells you what number it is in the EBCDIC encoding. So if you give it a space, it'll tell you 64. If you give it a letter, which is a hexadecimal C1, it tells you, oh, it's 193. These are some conversion functions for strings. If you have a string, you can convert to lowercase. You can convert to uppercase. You can reverse a string. You can take a string and say, convert it to all 0s and 1s and convert it to a bit string. That's cool. You can take a string and say, give me a version of it in hex. Or if you've already got it in hex, you can say, give it to me as a string, right? So you can put in a string of hex and get back the equivalent character representation. If you have a string, you can trim off the leading spaces or the trailing spaces or both. There's some date functions. There's lots of date functions. So you can say, give me the current date. That has no parameters. Here's an interesting one, date of an integer. You put in an integer and it tells you what date it corresponds to. All right. Jumpy finger on my mouse here. So you can put in a number here, and the number you put in is the number of days that have passed since December 31st, 1600 in the Gregorian calendar, and that'll tell you what date corresponds to that. These days I'm having trouble remembering that it is Friday. So these types of date functions aren't all that interesting to me at this point, but businesses do need them and make heavy use of dates. There are lots of math intrinsic functions. I just picked 2, square root, absolute value. There's lots more. There's trig functions. And this is one place where there's a lot of overlap between the COBOL intrinsic functions and the functions that you could get in the language environment. Okay, so there's some functions we can get if we're working in COBOL, some intrinsic functions that are built in and work great. What if I want to write a function myself in Enterprise COBOL? Well, you can't. Enterprise COBOL doesn't currently support user-defined functions. But as Tom Ross told me just yesterday, there are plans to incorporate this in the future. So the language will change. There is a workaround, though, and the workaround I want to suggest is to write a nested program. It's not going to be a function, but it'll be pretty close. So it turns out programs, I'm not going to spend a lot of time on this because this is mostly about intrinsic functions, but it's often the case we would like to have a function. So I'm going to give you an alternative and let you play with it a little bit. So programs can live inside of other programs. If you start thinking like this, though, if you start putting programs inside of programs, you want to start thinking much smaller. If you talk to most COBOL programmers and mention the word program, they usually have in mind these behemoth programs that are quite large. But in this context, we want to start thinking of programs as being much smaller, more like paragraphs, or maybe a couple of paragraphs together. So I want to start thinking much smaller. Oops, let me back up slightly. If I start doing this, I can pass parameters. I can always pass a parameter into a program and get something out of it. If I do this, the code that I'm writing in these programs is encapsulated, and the data becomes local. Programs that are outside of mine can't touch my data. So now I get this idea of localization of data. Everything's not global anymore. Well, that can be good, right? If I've packaged my code in a program, I can reuse it easily, because after I test it and make sure it works perfectly, I can reuse the program and never have to test that part of it again. So I can reuse it. It turns out calling a nested program is very efficient. It's like performing a paragraph. You don't have to take my word for this. You can look in the IBM manuals where they've tested this and describe it. And if you think about it, it makes sense that nested programs can be much more efficient than programs that are separately compiled. The COBOL compiler has all of the code available at the time the program is being compiled. All the code is together in one source module. And so the COBOL compiler can look at all of these little programs you're writing and make them work like paragraphs. But you get the advantage that you can now pass parameters in and get a value out. The data is no longer completely global. So if something goes wrong, I don't have to look through 100 pages of code to get it. I can look in a single program, which is more like a large paragraph. The last advantage I'm going to mention to this is younger programmers will immediately recognize this style of programming, because that's the style they've grown up writing. Okay, so everything has a flip side. What's the flip side to nested programming? My programs might look a little different. They're going to be less COBOL-like. And I'm technically not writing a function. I'm writing a procedure, but if I have a procedure that passes A, B, and C could be variables that are used for input, and C is the value I'm passing back. So it sort of works like a function. Just to give you, I'm not going to go into much more detail, but just to give you an idea of what it might look like. If I'm writing a program, I would just start out normally. When I'm finished with my program, if I wanted a function, I could start another program. When I'm finished with it, I have to add one new line in program B. So there becomes these ending delimiters we have to add when you start nesting programs. That's the only difference, really. The rest of this looks like a normal COBOL program. So does this one. The only differences are these delimiters. After I create my first little function, sort of function, I can start another one. And I can end it here. When I get to the bottom, I have to have a delimiter for the whole thing. If you don't like looking at these programs inside of other programs, you can do it this way. You can copy your programs to copy libraries and start building your own libraries of functions and include them. And then your program looks completely like a regular COBOL program. So this is a style that I've sort of adopted for writing many programs. I've found it helpful because over time, my copy library has gotten so large that all I really have to do now is write a driver program that calls these programs in the right sequence. And that is a big advantage because all of this code I'm including, I don't have to test like I do if I'm copying and pasting. So this is just a suggestion. You can write something that looks sort of like a function this way. Now, I've got some sample programs for this available on my website. One's called Function Demo. I'll point out where these are in just a second. One's called Function Demo, and there's nothing special about this program. All it is it creates a little data and it fires off a few functions, and they're not related to each other. So if you just want something you can use to experiment with your own functions, you could use this particular program. If you're interested in this nested idea I mentioned at the end, you could grab this program, Stacky. I'm not putting this out as the best program style in the world. All it is kind of a proof of concept program. It allocates storage, creates a stack, reads a file, pushes the records on the stack. Technically, it's not pushing the records on the stack. What it's pushing are pointers to the records on the stack. And it pops them off in reverse order and prints them out in reverse order. This thing runs in version 6.3 because of this allocate verb. Allocate is a new verb that can dynamically allocate storage. and I print out the pointers, so I had to do a redefinition on the pointers to get them to print. So if you're interested in that at all, you might check out Stacky. So that's, let me see if I can get this back and go here. This is my...
Dr. Wilbright?
Yes.
A couple questions.
All right.
Can we take a couple of questions maybe? All right, cool.
Sure.
One is, can we write a light program and access through the linkage section?
Can we write a what kind of program?
Light program. Carl, can you clarify with a comment to your question, perhaps? That would help. Okay, and I think there was another question that Paul just shared here with us, and that is, okay, a light program as in a simple function. Can we write a simple function and access through the linkage section?
You can write a function, you can pass it some parameters, and it can have a side effect of returning a parameter. So yeah, you could write this minimum function we looked at, you could write that. It's not going to be as efficient as the intrinsic function that's built in, but you could provide that yourself as a net program. Sure.
Yep. Okay, yeah.
That's sort of what I tried to do.
Hope that answered your question, Carl.
I'll tell you what, I'll put another little program on the...
Yep.
I'll put another little program on this site. These two links down here are links to the sample code. I'll add another one that just does a very simple function like min or something similar. And I'll put it as a out here later today.
Oh, that would be awesome. Thank you so much.
Any other questions or?
Yes, so Darshan, the other question
is there a reverse function?
Is there a reverse function?
Go ahead, Paul.
Oh, I'll go ahead and read it for you. Actually, oh, I'm sorry, that reverse function's a different one, but the one from the YouTube, it says, if I understood well, we can nest not only COBOL code, but for example, Java code too.
I don't think you can nest Java code. You can call Java, I think, from COBOL. The nesting of programs is for COBOL modules.
Okay, so hopefully that answered that. That came from the YouTube channel. And I'll go ahead, since I'm talking, I'll go ahead and the other question was out there. Is there the reverse function of integer dash of dash date? And then the person made reference to the manuals for date of integer and integer of date. So even myself, I'm not sure, but
I'm probably the worst. I'm probably the worst person to ask about date function.
Okay.
I usually don't know what it is, but honestly, I couldn't answer that question without looking at the manual.
Yeah, and I might suggest, Fernando, if it were me, I would actually experiment and find out what's the compiler capable of doing. You could always attempt it.
Right.
Good point. Yeah.
And I think that's all the questions I see.
Early on, there was another. Yeah, earlier on, there was one other. Will Dr. Wilbright explain parameters to include examples? And I think there were plenty of those that you shared, Dr. Wilbright, but I'll let you answer that.
Now, let's take a look at, we'll look at this program, Stacky. This is the COBOL code for it. It's just a regular COBOL type program. I think I'm passing parameters here. Let's see. Yeah. So here's Here's the push parameter. It has two subprograms. One's push and one's pop, pushing onto a stack and popping off of a stack. Right here, here's my procedure division where I'm using my stack, so I'm passing in a couple of parameters. Once I'm inside, if I change one of the parameters, it has a side effect in the calling program, right? So let's see if I can find my call. Here's a call, so I can say call pop using, here's the parameters I'm passing. And if I find pop, let's see, here's pop, I have a matching procedure division statement that matches up those parameters with the local names that I'm going to use, and those are names that are described in linkage. So I'm passing the parameters here. If I make a change in one of these parameters, it has a side effect back in the calling program. So I get the effect of a function. I can't use it syntactically like a function, but I get the effect of it. So there's an example of a nested program. It looks a little different if you're a COBOL programmer running into another program down the pike here. But if you don't like that look, as I said before, you can instead put these programs, as you debug them, you can put them in a copy library and do includes on them. And then it looks more like standard COBOL. So there's an example of the nested programs. The other example was just intrinsic functions. So this is a program. There's nothing much to this. I created some data areas, some arrays, and then I just do a sequence of computes here. So I can do compute smallest equals function min. You can try to do it with commas like this one does, but that's not going to work because of the spacing. So you have to code it like this or like that. So we're just trying to give you a few examples of calling these intrinsic functions in various ways. Here's my random call. Initially, you give it a seed, and it gives you back a number between 0 and 1. Subsequent calls, if you want the next random number in a sequence, you would leave off the parameters, and it would give you kind of the next number that was started at this sequence that this seed generated. Here's an example where I'm passing in a single dimension array and summing it up. And so it's just a collection of random calls to functions. It doesn't do anything. There's no flow to this thing other than just a sequence of functions you can look at as examples. And it gives you a working program that you could play with if you want to try some of the functions from the manual. So those are the two sample programs I've given. The other links are here. This was the webcast slides from several weeks ago, and these are the slides. If you want to look at the slides today, you can get them here. The rest of this is a COBOL course I put together, video course I put together. So if you're interested in working through an entire course, you could check out the rest of this. And that's about all I've got today.
Awesome. So I just want to elaborate on the parameter question, Dr. Wilbright. Our participant has added to their question. So early on in the presentation, for instance, there was a page where you talked about some intrinsic function examples, and in parentheses, for instance, it said A, B, C, D kind of thing. I think what our participant is asking is it possible to show a couple of examples of, what the function is and exactly what the parameters are? So I think, is there a specific function with parameters that you could share? Paul, can you hear me? Did we
I,
lose
can-
Dr.
I
Wilbright?
can hear you. And it appears
Okay.
Dr.
Dr.
Wilbright
Wilbright,
may have,
are you?
yeah, he may have to go out and come back in.
Okay, let me look into that.
Okay. For those of you that are on the call, I can tell you that Dr. David Wilbright has created some amazing material over the years. And his website, and if you just look for Dr. David Wilbright, you'll find lots of great information about assembler, about COBOL. He has decades worth of excellent material that he's posted on the internet.
Okay, let me try and invite him back in.
Okay.
Yeah, sorry everyone for the technical glitch, but he will soon join us back in, and we can get him to weigh in on that question. But yeah, Paul is right. The website that he shared with all of his presentations and the COBOL course, and he actually has an assembler course on there as well. We will link to that from our video replay as well. So don't worry if you've missed catching that. But keep your eyes on the link that I have shared, which is where we have all of our COBOL Friday webinar replays. So that would be a good place to get all of your resources, all COBOL related resources in one place.
And some of you may have noticed while we're waiting for Dr. Wilbright to come back, I posted a snippet link that is just a short version of what Sudarshana posted. It goes to the same place.
Thank you, Paul. It's always easier to have a short URL.
It was at least shorter. I'm not sure I made it short, but it helped me remember because I called it Enterprise-COBOL.
Yeah. Yep, I saw that. That was nifty. Okay. I see another question, but we'll give Dr. Wilbright a moment to join us.
And what I could do, I could maybe help with some of the questions while we're waiting for David.
Yeah, exactly. So let's take this one, Paul. Are nested programs compiled together and resulting as one executable? What are the pros and cons comparing this technique to independent called module?
I can't say I know the answer to that directly because the nested program technique that David was explaining, I have not used. However, the called modules that are separate modules, for example, a subroutine, you can compile a subroutine, make it an executable, and then when you compile the mainline program, you just include the subroutine so it can see both. But for the nested, I'm not sure. I'm not sure I can give you a solid answer without experimenting.
Okay.
Oh, someone mentioned lost the source code for assembler. There was some comments out there from Scott and others, and it is a common issue across large enterprises when there's source code that when people have sloppy internal practices, they have lost source code, whether it's assembler or COBOL. And so that does happen, but it's very interesting with COBOL on the IBM mainframe. So some would want to optimize their COBOL and take advantage of the performance of the latest hardware. So IBM came up with a product called, I got to remember the name of the product, but you can take the executable, the COBOL executable, where maybe you don't have the source for, run it into the product, and then the output would be a refined executable for that current hardware, increasing the performance. And I almost want to say ABO. I'm struggling with remembering the product name, But even though you've lost COBOL source code, it is possible to run it through a product and have it take advantage of the latest architecture to gain performance, because it unfortunately is too common of a problem where people have lost source code.
Were there any other questions on YouTube, Paul, perhaps?
Checking right now.
Okay.
No, no other questions on YouTube at this time.
All right. I think Dr. Woolbright, I think, is running into an issue. He's probably not able to join us back.
The good news is we got through most of his presentation. Oh yeah, somebody said like binary optimizer. That's correct. I believe, and I think it began with A, like automated binary optimizer. Someone can actually, that's a Trivial Pursuit question for an IBM product. I'm not a marketing guy, so I don't have it memorized. Oh, thank you. Somebody posted a link. Oh,
yeah.
That's right.
That's the GitHub repo, yeah.
Yeah.
Mm-hmm. Thank you, Scott. But like I was mentioning earlier, the developer.ibm.com is sort of your one-stop hub for all things COBOL. So if you bookmark that one link, not only do you have all the webinar replays there, we also have the webinar events, so you can register for the upcoming events. And there is a wealth of other resources that we've put out there. There are code patterns to try. There is blogs, articles, and some Z trials as well to just play with how and in what different ways COBOL is actually being leveraged. So there's a couple of trials there which are pretty interesting too. So you definitely want to check out the developer.ibm.com link that I've shared earlier. That would be great. Yay, we have Dr. Woolbright back. Welcome back.
Thank you. Sorry, I don't know what happened.
Yeah, we've just been chit-chatting. So I think Paul answered part of that question for sure, but we'll just pick on your brain a little as well, Dr. Woolbright, if that's okay. Are nested programs compiled together and result in one executable, one same executable?
Yeah, that's why they're efficient. That's the beauty of it. It's all together, and so the compiler sees all and knows all and can make it work like a paragraph, basically.
So then that answers another question that was a follow-on question in the YouTube channel. They were asking about JCL for the nested, and it's the same JCL to compile because it's all in the same module.
Right. Now, one thing I didn't mention, we didn't go into all the details of it. There's a lot to know about it, but you can leave off divisions, like you can leave off the environment division if a particular program isn't reading a file, you don't have to have it. So a lot can be left out to make the code tighter.
Mm-hmm. So a follow-up to the nested compiling question, Dr. Woolbright, is what are the pros and cons if you were to compare this technique as opposed to calling independent modules?
There's more overhead in calling a separate module, and you're probably not going to be willing to get the fine-grained modularity in a separate program that you could be achieving through a nested program. We need to think of these nested programs more like paragraphs and not programs. In any other language, it's called a procedure, but we're calling them programs, and so to most COBOL programmers, they're going to think, oh, these are large. They don't have to be. And we can get the efficiencies of a paragraph with these things. So we need to think smaller. If you're going to try this style out, you want to think smaller.
Okay, that makes sense. Okay. I think another question just popped up. So nested programs could be regarded as a method in newer languages, a way to have local variables instead of only global ones.
I'm sorry, say that one more time.
Okay, so I think this Fernando is thinking about this as, can we look at nested programs then as a method in newer languages?
Yeah, it's sort of like a method. Exactly.
Mm.
That's why younger programmers will recognize this style, because that's what they write. Right?
Okay, right, yeah. So the follow on to that was also, so is this a way to have local variables instead of only global ones?
Yeah, exactly. So everything
Okay.
that's in your little nested program is protected from all the other code you're going to write. Right? That's a good thing.
Yep. Yep. Okay.
But you
Yeah.
get the efficiencies of having global data. You get the efficiency of global data, but you get the design protections of local data. So it's a win-win, I think.
Okay. Simplified to be methodical and consistent.
So while Sudarshan is reading
Okay.
that, Dr. Woolbright, I loved your example with the tables, that trick that you were doing with the tables in intrinsic functions. It never occurred to me. That's a very slick technique.
That's really a powerful idea. When you combine those two, it makes those functions perfect. You know?
Yeah,
It's like,
absolutely.
great, I don't have to write the loops. And it's right, it'll be right, and you don't have to think about it much. So.
Okay, I think there are no other questions. There's just some chat on the side. Tables with intrinsic functions reminds me of vectorized functions in R. Okay. All right, yeah.
Another comment from someone that works with COBOL almost every day, because he's a pro, he actually said, I wasn't aware of that all function with the tables. And so you were able to help a pro. He just never was aware of this all function I shouldn't call it a function, because you use the keyword all. And he just thinks that's awesome.
Yeah, when I saw that, I couldn't believe it. I thought, geez, this is great. Yeah. I'm not a professional programmer. I don't make my living doing this, but I sort of look at it as my job just to test everything and to try stuff and see what the limits of these compilers are, and just to try it out to the max. So I can't answer every question that everybody has, and I certainly can't answer many practical questions of people actually having to do this day to day in the real world, but I look at it as an intellectual exercise. It's just, what can I do with this language? What can I get away with now? So that's kind of what I try to, and how should we write this stuff these days? I mean, the language is completely different. It's nothing like it used to be. So we really need to rethink our approach. How should it look? And open up our mind to different possible ways of going about it.
Yeah, and two comments. One is that sometimes the pros don't always have time to go back and do that. That's why it's nice that educators research. And I think it was the CEO of COBOL Cowboys, it's a company. He said that the old COBOL was like getting off of a bicycle, and the new COBOL's like jumping on a Harley.
Yeah, well, there's a reason this language has survived for 60 years, and that the people who caretake this language have made it better. I wanted to mention this on the webcast. I think if you had to bet, this language has survived 60 years. If you had to bet on what language is going to survive 60 more years, what would you bet on? Well, you could do a lot worse than betting on COBOL, because there's a tremendous code base. It's not going to go away. it has probably a better chance of living 60 more years than a lot of other languages. How many languages are going to be around in 10 years?
Mm-hmm.
Think about it. As a person that teaches languages, I think of all the languages I've learned that are gone.
I wonder if
You know?
I wonder if they'll just deprecate Java altogether. Everything will be JavaScript. I shouldn't say that, but
Yeah.
and the other thing about COBOL and that's a great statement. But one thing about COBOL also is that they always had these rules-based things they were building in the last couple of decades. Well, COBOL is a rules-based language, in my opinion, because you're really putting the logic of the business in there. So when you talk about rules-based things, you're building rules in there.
And the other astounding feature of this language is it's backward compatible.
Yep, exactly.
How many languages are backward compatible? Very few. It's like if you program in Python, that language bifurcated at some point. You know, it's like it's a completely different language than it was, you know, and it's not backward compatible. So it's
when they built Java is write once, run anywhere. It depends upon the time frame you're running it in.
Yeah, and then the machine
AVM is different.
You're running on, right?
Mm-hmm.
So.
Yeah, and I think some of our participants think that for sure COBOL, so they agree with you, Dr. Wilbright, and they think that possibly C might live that long as well. So, yeah, yeah.
Obviously. Well, let's hope we have programming languages 60 years from now, right? Worry about that. You know?
Absolutely. But I was, you know, to your point earlier about how you love, you know, really experimenting and testing all of the features that come out just from you being an educator's point of view. I was going to say it is experimentalists like you that keep the world going around. So thank you so much, Dr. Wilbright. Your session was as insightful as it always is. And like I said in my email the last time, I wish I had you for a professor when I was learning COBOL in college. I would have really, you know, understood the value that this language brings. So
thanks.
Thank you again.
Both of y'all for letting me be on here. It's been a pleasure.
It's a pleasure to hear your thoughts and inputs, and you know, just to be able to learn from you. So thank you for taking the time on a Friday morning, and thank you to our audience, both here on Crowdcast and YouTube, Facebook Live, if we were able to go on there, for being with us. And we'll see you again next Friday. Next Friday is going to be a really interesting session as well. Come prepared with your laptops ready to go. Bring your own device, BYOD. Jeff Beastie will be joining us to help you and walk you through writing your first COBOL program. As it turns out, our poll, just in case our audience is curious, the folks who took our poll, we have about 50-50 on the poll. 56% are new to COBOL and 43% are not new to COBOL. So we have about a 50-50 audience here, so which is great. It's always nice to see some of the experts on here as well, to be able to chime along with us and bring in your point of view and perspective. That's about it for today then. Thank you all so much and see you next Friday. Have a wonderful Memorial Day weekend, everyone. Stay safe, stay healthy. Bye.
Bye-bye.